Hello everyone, for today's lesson, 9.3, we'll be learning about speed. Now our learning objectives are to practice converting rates into different units, in this case, speed, and we're going to learn how to calculate the average rate. Now, you may have already know what speed means, okay? But the most general definition is, speed is a type of rate. And the rate that we're comparing is the distance traveled over the time taken. So that's how we define speed. Okay? Now with this formula, we can rearrange it to get the values of other things. Okay? For example, we can say the distance traveled equals speed times the time taken. Okay? Or the time taken equals the distance traveled divided by speed. For our first practice question, we're given this information. The walking speed of Ms. V is 1.3 meters per second. Find the distance she can walk in 10 minutes. Okay, now remember the formula that we just learned earlier. Distance traveled equals speed times time. Now an important thing you have to note is that the speed has to correspond with the same unit of measurement for the time. Okay, here we have 10 minutes, but the walking speed is 1.3 meters per second. So we have to convert minutes into seconds. Okay? So we have 1.3 meters per second times 600 seconds. There's 60 seconds in a minute, and we have 10 minutes here. So 60 times 10 is 600. Okay? If we multiply those two numbers, we find we get 780 meters. Okay? Or we can express it as 0.78 kilometers. Okay? Now for B, find her time taken to walk 1 kilometer. Okay? So we just learned earlier that the time taken equals distance traveled divided by speed. Okay? So again, we have to convert kilometers into meters because the speed is given as meters per second. So we convert kilometers and meters. We know 1 kilometer is 1,000 meters, and we know her speed is 1.3 meters per second. Now, if we take out our calculator, we'll find that 1,000 divided by 1.3 gives us 769.2. Okay, or we can just round the nearest whole number. Let's just say 769 seconds. Okay, so it takes her 769 seconds to walk 1 kilometer. All right, for practice, I'd like everyone to try page 18, number 18, the triad question. Next, we're going to learn about constant speed and average speed. Now, if objects maintain the same speed throughout its course, we can say that the object is moving at a constant or uniform speed. So with the previous example I gave, with Ms. V walking 1.3 meters per second, that's a constant speed. If that speed does not change, then we say it's constant or uniform. Okay? Now, if the speed of an object changes over its course, then we can calculate its average speed instead. Okay? Now, the average speed is calculated by finding the total distance traveled over the total time taken. Okay? Now, keep in mind that the average speed is not the average of the two speeds, or several, 3 or 4 speeds that you get. Okay? Now let's do a practice question involving average speeds. Okay, Mr. Fong traveled 13 kilometers on his bike for half an hour, then traveled another 2 hours at a speed of 16 kilometers per hour. Now question A asks, find the average of both speeds. So the average of both speeds would just be the sum of the speeds divided by the number of speeds we have. So in the beginning, he travels 13 kilometers for half an hour. So 13 kilometers for half an hour. Okay, that's speed 1. Okay, so if we simplify that, we need to get rid of this denominator here. We multiply both the top and the bottom by 2. That gives us 26 kilometers an hour. Okay, speed 2, that's already given. That's 16 kilometers an hour. Okay. So the average of both speeds will be 26 plus 16 divided by 2, okay, which would be 42 over 2, and give be 21 kilometers an hour. All right, now let's look at B, the average speed for the whole journey. Now, remember the definition of average speed. It's the total distance traveled over the total time taken. So the total distance traveled would be we traveled 13 kilometers for the first half hour. Then we travel for 2 hours at a speed of 16 kilometers an hour. So 16 times 2. Okay. And we divide it by the total time taken. Okay. Our first leg of our journey took half an hour, and the second half, or second part, took 2 hours. So 0.5 plus 2. Okay, that gives us 13 plus 32 would be 45, and we divide that by 2.5. Okay, and our answer should be, maybe we can simplify this as 90 divided by 5, and that gives us 18. Okay, so the average speed for the whole journey is 18 kilometers an hour. Okay, so notice that the average speed is not the same as the average of all the speeds. Okay, so the average speed does not mean the same thing as the average of all the speeds. Okay, next up we have conversion of units. Now we've already done some practice on this earlier, but it'll help to do this more practice again. Okay, now for speeds, the most common units that are used to measure speed are kilometers an hour, meters per second, and miles per hour in some countries like the United States. Now, if you're not familiar with how long a mile is, 1 mile is 1.609 kilometers, approximately. Okay, so let's do a practice question. The speed limit in California is 75 miles per hour. Express this speed in kilometers per hour. Okay, so we have 75 miles per hour. Okay. Now, we know 1 mile is 1.609 kilometers, so we just multiply it by 1.609. Okay. And if you take out our calculator, we'll find that 75 times 1.609 gives us 120.675 kilometers an hour. Okay, next one is a bit more difficult. Express that as meters per second. Now, we can take our answer from A. Okay, we have 120.675 kilometers an hour. Okay, then we need to figure out how many meters there are in a kilometer and how many seconds there are in an hour. Okay, now we know there are 1,000 meters in a kilometer, and we know there are 3,600 seconds in an hour. Okay, so what we do is we have to multiply it by 1,000, okay, time, and divide it by 3,600. Okay, so what we want to do is maybe take this out, multiply it instead. Okay, and our answer should be, if we take a calculator, 120.675 times 1,000 divided by 3,600, and we have 33.52 approximately. Okay, 33.52 meters per second. So for practice, I'd like everyone to try question number 19 on page 19 and question number 20 on page 20. Okay, our final example comes from the textbook. Trains A and B leave a station and travel in opposite directions at the same time. Train A travels at 80 kilometers per hour and train B travels at 100 kilometers per hour. After how long would it be 135 kilometers apart? Now, a diagram in this case will be helpful for you to illustrate how exactly this problem works. Now, both trains are at the station and they're moving in opposite directions. Okay? So that means both of their movements will make them further apart. Okay? Now, we can have t represent the distance traveled by A in t hours. So t in this case actually represents time. Okay, so the t for train B, okay, distance traveled would be 100t. Okay, because it's traveling 100 kilometers an hour, we put 100 in front of t. Okay, so 80t plus 100t equals 135. Okay, we simplify that, and we find 180t equals 135. We isolate t, and that gives us t equals 3/4. So that means 3/4 of an hour, and that of course is not 75 minutes, but rather 3/4 hours would be 45 minutes. Okay. Now I want everyone to do the triad question, number 21. Okay. Cars A and B leave the same place and travel in the same direction along a straight road. Car A travels at 60 kilometers an hour and car B travels at 72 kilometers an hour. After how long will be 8 kilometers apart? Now, I'll give you a hint. For this question, we do not add the two numbers, okay? Because they're traveling in the same direction. So if you think about it this way, if you have one fast car, one car going fast and one car going slower, okay, the distance between them will not be as great as if they drove apart from one another. Okay, so that's my hint. Okay, it's not adding the two values, but doing something else. Okay, try to figure out what that is and try to solve the problem.